Hey, welcome back to your favorite technical mathematics class. We're going to take a look at trig ratios today, define those. So let's take a look here. Just a little intro from your textbook. You know, a lot of application problems require use of trigonometry, such as projectile motion, light refraction, navigation, surveying. All of these can involve trigonometric ratios. So let's define the trig functions using right triangle trigonometry. So if you've got an angle here, theta, notice the theta right here. The sine of theta will be the opposite side over the hypotenuse. So the opposite side length over the hypotenuse. So that's the sine is opposite over hypotenuse. So SOH. And then the cosine is the adjacent side, so the adjacent side over the hypotenuse. And then the tangent is opposite over adjacent, opposite over the adjacent side. That's the tangent of an angle. And then notice they're reciprocals. The cosecant flips the sine around, so instead of opposite over hypotenuse, it flips it around, hypotenuse over opposite. The secant flips around the cosine, okay, and so on. So here's how you remember it. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Toa, tangent's opposite over adjacent. I actually learned the trig ratios as, oh heck, another hour of algebra. That's how I learned them. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Okay. So let's find the 6 trig ratios in fractional form for angle A and angle B. So sine of angle A, cosine of angle A, tangent of angle A. SOHCA to OH, so O heck, or if you want to do it, another hour of algebra, or SOHCA, SOHCAHTOA. Alright, so the sine of angle A. So I look at angle A, I say, well, here's angle A. Who's the opposite side to it? Well, the opposite side is the 3. Who's the hypotenuse? 6. So the sine of angle A is just 1/2, 3/6, which is a half. The cosine of angle A, again, here's cosine, so who's right next to it? Who's the leg right next to it? Right here. That's the adjacent side to angle A. So the adjacent side is 3√3, the hypotenuse still 6. Well, 3/6 is 1/2. So you got 1√3 all over 2. The tangent of angle A is the opposite side, so 3, the opposite side, over the adjacent side, which is 3√3. Well, 3 over 3 is 1 over √3. But you do have to rationalize that. No square roots on the bottom. So multiply top and bottom by √3. So √3 over 3. Now, it says all 6 trig ratios. So not only do you have to get the sine, you got to get its reciprocal. Cosecant. Well, the cosecant is just 1/2 flipped around. So instead of 1 over 2, it's 2 over 1, just 2. The reciprocal of the cosine is the secant. So instead of opposite over instead of adjacent over opposite, it'll be hypotenuse over adjacent. In other words, instead of √3 over 2, it'll be 2 over √3. And then you do have to rationalize that. So multiply by √3, top and bottom. So you get 2 √3 over 3. And then finally, the reciprocal of tangents, the cotangent. So instead of 1 over √3 before you rationalized it, it's √3 over 1, which is just √3. Okay. Now that's for angle A. We have not done all 6 trig ratios for angle B, but I do need to clear some space to do angle B here. Alright, so now I'm looking at angle B. So with respect to angle B, the opposite side is now right here. The hypotenuse, of course, is still the 6 because the hypotenuse is always opposite the 90 degree. The adjacent side, adjacent means next to, the adjacent side is right next to the B, the leg right next to it, so the adjacent side is the 3. So when we go through, we do sine of B, again opposite over hypotenuse, cosine will be adjacent over hypotenuse, tangent opposite over adjacent. Okay, so sine of B, opposite side now is 3 root 3. Hypotenuse is 6. Well, 3/6 is 1/2, so root 3 over 2. Cosine B, the adjacent side is 3. Hypotenuse is 6. 3/6 is 1/2. Tangent of B, opposite side over the adjacent. We're left with root 3 over 1, which is just root 3. Do the reciprocal, so the sine, the reciprocal of the sine is the cosecant. Cosecant, instead of root 3 over 2, will be 2 over root 3. Don't forget to rationalize it. So 2 root 3 over 3. Reciprocal of the cosine is the secant. So instead of 1 over 2, it's 2 over 1. Reciprocal of the tangent's the cotangent. Instead of root 3 or root 3 over 1, it's 1 over root 3. And then you do have to rationalize it. So root 3 over 3. Alright, so those are the 6 trig ratios on that first one. Now how about this situation? Determine the sine of A and the tangent of B if you're given the side lengths A being 1.7, B being 1.8. Now when you're finding the sine of A, you have to know the opposite side, you have to know the hypotenuse. So you look at A and you say, well, that's the opposite side. It's going to be 1.7. The problem is the hypotenuse. What's the hypotenuse? Well, we don't know. So before you do anything, you got to find it with the Pythagorean theorem. A squared plus B squared equals C squared. So 1.7 squared plus 1.8 squared equals C squared. You punch in 1.7 squared and you get 2.89. Punch in 1.8 squared, you get 3.24. Add those up. You get 6.13. And then you square root that. So your C ends up being 2.476. So C is 2.476. That's the C right here. 2.476. Alright. So now I go back to finding the sine of A is the opposite side. 1.7. I wrote that already. 1.7 over the hypotenuse. 2.476. And then I can just go ahead and divide that. 1.7 divided by that 2.476, 0.687. 0.687. I'm not sure what it'll have you round to, but sine of A, let's say it rounds to the nearest hundredth. 0.69. Tangent of B. Tangent of B. Well, tangent's opposite over adjacent. TOA, right? So I've got TOA, T-O-A. But this time we're looking at B. Here's B. The opposite side, opposite B would be this one, 1.8. 1.8. The adjacent side would be the 1.7. So 1.8 divided by the 1.7, you get 1.059 or 1.06. That's the tangent of B, 1.06. All right. So be careful on what who's the opposite and who's the adjacent side because it depends on what angle you're looking at. Let me erase this. I gotta have some room for this next example. Alright, now it says, well, what if the tangent of A is 5? So let's go ahead and draw this right triangle. They say, here's your A, Here's your B, here's your C. All right, tangent of A. Remember, tangent, oops, come on. Tangent, oh my goodness. Tangent is, let me go up here. Tangent of A, remember, tangent's opposite over adjacent. Well, if it's 5, what's the number on the bottom? Well, it's 5 over 1. That means, with respect to A, the opposite side is 5. The adjacent side, right, here's your opposite side to it, here's your adjacent side. The adjacent side is 1. So what's the sine of A? Well, we're going to have to find out what the hypotenuse is. So let's do the hypotenuse first. So 1 squared plus 5 squared equals c squared. So 1 plus 25, 26 is c squared. C is the square root of 26. So c equals the square root of 26. And now we can do it. Now we can find the sine of A, because the sine of A is the opposite over the hypotenuse. So the sine of A, with respect to A, the opposite side is 5. The hypotenuse is that square root of 26. Now you got to rationalize that. So times it by square root of 26, square root of 26. You get 5 root 26 over 26. That's the sine of A when the tangent of A is given. That's 5. All right, well, thanks for listening. See you soon. Enjoy your trig.